This is another problem from codeforces. Uh, it's numbered as 1536 and the problem number is C. 1536 problem C. So this is called as Duluth and Kea problem, and uh, it has a big problem statement and you can read through it, or I can show it to you on screen and you can read through it. It's pausing and this in it has like the problem is simply stating that as you have a blackboard and it has some strings values written on it you, like dk and any kind of string it has written on it. So we have to make a cuts of continuous like contiguous spaces and like the maximum pieces we can split. uh, we have to find that like any split we are making, there are some constraints, but any split we are making we have to find that maximum splits how much we can so like we have to return this splits numbers also as an array format, and the constraint is that the ratio of that both of them should be equal, like they should not have that equal, and they should have equal number of b and a, and in that sub split if this was the split one of the split, so it should have these two cases one is to one. So given output as prefix from 0 to -1, so we have to we can think of it as like there is one simple rule that any split we do, it was also given in the problem like a by b equals to c by d, so these two are equal. So let's take a split of that KD ratio of A by G and KK ratio as B by G. So this is the ratio in the simplest form, like A and B. If there is a ratio of that, and like we can, so we have to find that KD and KK pair, and we also have given like M is the GCD of AI comma BI. So this is the given M pair also. So AI and BI we take is this going to be. So what this means is that uh, the G here also signifies as the GCD of that AI and BI. So we have taken AI and into KD. So we know that GCD of M is, so we have to do here was that we have taken KD ratio as A by G and KK ratio as B by G here. And the G here is the GCD and of that AI and BI which we are taking of any backups, and we have to find KK and KD pair, KD and KK pair of that, and we can simplify this as like if we take M as GCD of AI and BI, of we can simplify this as this. So any good partition is the like maximum number of continuous pieces like of M, and where every piece has same ratios. So we we can think of it as we have different pieces, and like we will count these pieces based on like any pj piece. We can count of that dj comma kj which is proportional to kd comma kk. So these are all simplified to the same ratio. How many times it appears, we are going to count on this. So we can solve this based on this, and we have selected exact c times of pair of that prefix, and like if we take s of 1 to j1, s of 1 to j2, there are different kinds of like prefixes. We will have maximum number of pieces of that kd to kkd ratio. So we can solve this in this way. So this is a good problem based on that, because like this uh, continuous like pieces where it has is mostly used in many of the problems we can see on the GCDs, uses, and we can use this as like code this also.
So this is the problem, and the solution of this problem, as we have discussed from that, it is going to be this. So the code is going to be something like this. So what we are going to be doing here is that um, we will make a GCD function, and this is a normal GCD function, like using long uh, for the integer two numbers. We will make a function where GCD array. So these are all not required, but you can use them as I have used them for this uh, calculation, but you can make them like a vector. If you, there is one solution I can discuss with you where you can use like thinking, I was thinking a solution where you can use this vector also. So we will make a count map, and where it's going to be the pair of int comma int with int. So this is for like the kk and kd and kk. So we have to make them pairs, and we have to maintain the frequency of that. So this is kk kd, and that is the frequency of that. So we will make a lambda function here. So a lambda function here will be a normalized function. So what we will do here, as we take an input of count d and count k, if the count d is 0 and count k is 0, we can make a pair of 0 comma 0. So this will contribute to our initial thing, which is called like as a base case, like initial like case where both counts are 0, so make pair will be 0. But we can then iterate through GCD and then return a make pair of count of that, because the count d on count k, and we divided by g uh, for a and b. So this is a recursive calculation to normalize this. After that, how we are calculating it actually is we will iterate through all of the things, and if we found d, so it is going to be a plus, and if we found k, it is going to be b plus, because kkd and and kd, there are two uh, things we have to know. So we will just update this based on the inputs, or like we based on the inputs we are given. We don't have to do anything about other than this function, other than update a and b, and the main parts come from how we normalize this. So we will make a pair of the key, and like we will return from this value as count of k, count of d, and count of k. After that, we will just increase this key. So this is going to be in the for loop. So we will increase this key for every key of that count. So this is updated on first, then we will do this part. After that, we can just output this result, and it is going to be end of the and since